Catching the Light with the Rainbow Nation took place in September 2013 and was a large-scale, ambitious outreach event intended to increase the popularity and understanding of chemistry in Mafikeng and Durban, South Africa. The event was centred on a series of school workshops exploring chemistry, light and colour, with rainbow as the central theme.
In this workshop, students made their very own dye-sensitized solar cells from everyday materials. The students were taught about the importance of solar and renewable energy, as well as how dyes can absorb visible light. Blackberries and blueberries were crushed and filtered to extract the juice and produce a natural dye. Glass electrodes with titanium dioxide films were dyed in the fruit juice. This allows the cells to convert visible light into electricity. Fruit teas were also tested as dyes.
Quick fingers. There we go.
A separate glass electrode was coated with carbon from a pencil to act as a catalyst. Finally, a conductive liquid electrolyte was injected between the two glass electrodes to complete the circuit. The solar cells were tested for performance outside, inside and under a bright lamp.
Right, that's more like it. Super.
The students were amazed at how easy it was to make a solar cell.
First of all, did everybody enjoy?
Yes.
Does everybody love science now?
Yes.
That's good. Is everybody going to study chemistry? No. So I'm going to now try to make some liquid light. There we go. Reaction between luminol and hydrogen peroxide. So I like this reaction so much, I do it 3 times, but with a different dye. So there you go. Anybody seen Predator? It's an old film now, but that's Predator blood. And this one's for the milkshake freaks. So when they're ready to emit the light, it's not UV anymore, it's visible. So we get the whole mixture of dyes generating lots of different colours as they dissolve. That's fluorescence.
There we go, the cable stopped it. So there you go, a solar cell made it on. So it's really simple, it's from everyday materials.
One of our workshops was based on cyanotype photography, also known as blueprints. This workshop was delivered in Mafikeng to about 200 students of age 12-15 over the course of 1 week. So we showed the kids how to make blueprints, and they showed us how to dance while their paper was developing in the sun. This teaches the children how chemicals can react with light whilst getting them to produce lovely prints. In this workshop, the children learned all about acids and bases and how to make their own pH indicator.
What colour is that?
Pinky.
Bicarbonate, the first one we did, sodium carbonate. That's base, yeah? Fill that out. There you go. Yes, sir. So that proves it. Neutral, acid, base. Here's your red cabbage as an indicator.
At the Early Learning Centre in Mafikeng, the children designed and painted t-shirts with different fabric pens and paint. Over the week, over 260 children between the ages of 1 and 6 years old designed and made their own t-shirts. The t-shirts will now be the school uniform every Wednesday. When all the children had made their t-shirts, we had a fun day of play and sports. The children loved the new sports equipment for the school, and the kids had just as much fun as we did, and it was definitely hard to leave them at the end of the week. five. High five. The Catching the Light team consisted of 8 scientists from Bangor University in North Wales, 6 scientists from Specific in Swansea University, 4 scientists from the chemistry group Swansea University, and 5 scientists from the University of KwaZulu-Natal in South Africa. This scientific outreach event involved a week of workshops in the University of KwaZulu-Natal in Durban for local high schools and a week of workshops in Mafikeng. Over the 2-week period, over 1,300 school children attended the workshops.